on this lesson, we're going to go over factoring. Now, if you think about it right now, and you remember from last year how to factor and it's perfect and everything like that, just take a few notes, speed through them, check with me on the 4 questions, everything like that. But if you forgot how to factor, just go through it with me. The other thing is this, I might have a different way than you learned it. Again, the way you learned it, if you remember, and it works all the time, stick with that. But I'm going to show you my way, more of a procedure way than some people do it. And if you like my way, do it. All right, so factoring, which is very, very important this year. There are some concepts that we do this year that the first step is to factor. So if we can't get this down, it's going to make those other concepts a little bit more difficult, okay? So factor, what multiplies to give the answers? Undoing the distribution. So remember how last class we multiplied polynomials, specifically binomial times binomial. Now we're going to factor and actually go backwards from that multiplication. Now we're not only just doing binomial times binomial. Sometimes all there is what we call this greatest common factor. And if we get higher in mathematics, we'll do even bigger factoring with trinomials and stuff like that. So what we're going to do is review some stuff on greatest common factor. You always want to check for the greatest common factor first. So greatest common factor, well, you want to look what's in common. So on example 1A here, what is common between 3 and 6? Hopefully you're saying 3. So what I'm going to do is factor out of 3. Now, some of you do not have to write this down. You can automatically see it and move forward. But if you want to know what that means, well, remember, the opposite of multiplication is division. So it's almost like I'm dividing each of these terms by what's in common, which is 3. So if I said 3x divided by 3, that leaves x. Negative 6 divided by 3 is negative 2. Now I can quickly see if I did this correctly by almost distributing back in, right? 3 times x is 3x. 3 times negative 2 is negative 6. Now that's great for the greatest common factor when it's just a number, but a greatest common factor can also be the variable. When you see that they have a variable in common for all the terms, not just 2, if it's a 3-term one, but all the terms, then you want to do the smallest exponent. Okay, so if I look at B here, what do they have in common? Let me look at the numbers first. Well, 4 and 2, what do they have in common? They have a multiple of 2. Then if you look at the variable, they both have x's. So what I'm going to do is take an x in the smallest exponent. Well, let's see, that's a 2, and this exponent's a 1. So I'm going to take out just an x to the first. Now, again, if you want to see it visually, we can divide it by that 2x. Now, 4 divided by 2 is 2, and x squared divided by x leaves an x. Remember, that's the subtracting of the variable, or subtracting of the exponent, sorry. And this one, 2x divided by 2x, well, anything divided by itself is 1. Again, I can check this by going multiplying it out. 2x times 2x is 4x squared. 2x times 1 is 2x. All right, and see, we have a trinomial here. So again, the first thing I'm going to do is a greatest common factor, see what they have in common. Let's look at the numbers. 8, 10, and 6. Well, they're all even, so I can take out a 2. And they all have x's. And the lowest exponent, let's see, 3, 2, and this one again is 1. So I'm just going to take out an x. All right, and again, I'm just going to write it down so you can see. Eventually, you might get quick enough that you don't need to see this 2x here. 8 divided by 2 is 4. And x cubed divided by x, well, again, subtract 3 minus 1 is 2. 10 divided by 2 is 5. X squared divided by x, that's 2, minus 1 is 1. Negative 6 divided by 2 is negative 3. And x divided by x, well, those cancel out, so I'm just left with this negative 3 here. Again, I can check my work by distributing, see if I get that same answer. Okay, from here, when you check for greatest common factor, then we can see if the remaining polynomial can be factored further. So we're going to take this one step at a time. In example 2, what we're going to do is we're going to look at trinomials, but specifically that leading coefficient is 1. Okay, leading coefficient is 1. So if you see all 4 of these questions right here, there are no greatest common factor, because I want you to focus on factoring that trinomial. So some of you know tricks when it comes to this. I'm going to keep it in the same process that we would be factoring if this coefficient out here was not 1. So what I'm going to show you is in a basic quadratic, we usually have a x squared plus bx plus c. I'm labeling this because we're able to follow a process and use this A, B, and C. And this way you'll always know what I mean by A, mean by B, and mean by C. So the first thing we have to do is multiply A times C. So I'm going to write the basic process right here. We're going to multiply A times C and get a certain value, okay, a certain number. Then we're going to say, what two numbers add together to multiply, or what two numbers multiply to give you this number, but when you add them together, they get you that value of B. That's going to be step 1 if there's no greatest common factor, okay? So right here for A, the first thing I'm going to do is say 1 times 8. So 1 times 8 is 8. So we're going to ask ourselves, what two numbers that multiply to 8 add up to our B, which in this case is 6. Okay, so what two numbers do you multiply to give you 8, but add to give you 6? If you need a factor paper, just come up and ask me. Multiples and factors, please come up and ask me and I'll give you those. But hopefully you're thinking, wait, that's 4 times 2. 4 times 2 is 8, and when we add those two together, we get 6. Okay. Now remember how I taught you how to do multiplication by the box method? We're actually going to do the same thing. We're going to do a box method, but we're going to go backwards. Okay, so when I do my box method for this, I'm creating a 2 by 2. Okay. Now when we multiplied, remember we put our binomials up here, and then we multiplied to get our inside. What we're actually going to do is fill out our inside and go find our outside. So this first term is going to go in this upper left-hand box. So x squared. This constant here is going to go in the lower right hand. And what do we fill the other two boxes with? Well, we fill them with are these two numbers we just found. Now, really, when we had 6 here, what was it? It was 6x. So what we're actually doing is saying to ourselves, this is 4x and 2x. When we put these in the 2 remaining boxes, it does not matter which one's which, because no matter what, we're going to come out with the same answer, okay? Now, from here, what do we do? Well, now we're going to say what's in common, like a common factor, right? So let's look at this left vertical here. What's in common between x squared and 2x? Well, the answer is x. Let's look at this right-hand side vertical. What's common between 4x and 8? Some of you might automatically go, oh, they're even, so 2. But be careful, we're looking for the greatest common factor. So the greatest common factor between 4 and 8 is 4. Okay, now let's look at the top horizontal. What's common between x squared and 4x? X. What's common now in this lower one between 2x and 8? 2. Now, of course, we're going to talk about negatives and stuff in a minute, but so this leaves our answer is going to be x plus 4 times x plus 2. If you decided to write it as x plus 2 times x plus 4, that is perfectly fine. Considering multiplication is commutative and you can switch it, right? 3 times 4 is the same as 4 times 3, okay? So this is our answer. Now, of course, what factoring was great and what I highly recommend, especially on tests, if you have to, work backwards and test your answer. Multiply this out. See if you get the same question. Okay, let's try a new one. For B here, and this is why there's 4 different questions. Do you guys see how this changes? This is now subtraction, and this stays addition. So we're going to try this in its new way. So again, first thing I'm going to do is multiply A times C. So that's 1 times 10. So we're saying what 2 numbers do you multiply to give you 10? But when you add them, it gives you negative 7. All right, so factors of 10 is 1 and 10. That doesn't give me 7. But what gives me 7? 2 and 5. Now, what is it that I wrote down that looks incorrect here? 2 plus 5 is 7, and we want it to be negative 7. How can we make that possible and still have a positive 10 here when we multiply? Well, a negative times a negative is a positive, and a negative plus a negative is a negative. So now does that look correct? Hopefully you're saying yes. So now let's make our box. I didn't give myself enough room, did I? All right, let's remember in this top left hand, we put that first term there of y squared. Right lower is that constant. And then remember the other two are filled with these 2 numbers, but remember, what is that? It is y, right? And we got that from y. So negative 2y, negative 5y. Okay, now we're going to find the common factors. Right here on the left-hand side, y. All right, this is where it gets tricky. Let's go on the right side, vertical. What's common between negative 5y and 10? Hopefully you say 5. Now, if it's negative here, you're going to put negative. If it was positive, we would have positive. Okay. Right here on the top, straight across, we get common as y. Right here on the bottom, well, 2 and 10 would be 2, but of course, see how this first box right here is negative? So it's a negative 2. Now, what's going to help you with your negatives, again, is when you write your answer. So in this case, we have y minus 5 times y minus 2 is checking your answer by multiplying to really make sure you have those signs correctly. Okay. You'll see that when we get to C and D here. Okay. A is still 1 times negative 12. All right, so we're saying what two numbers multiply to give you negative 12, but when you add them together, it gives you positive 4. Okay, one thing I want you guys to keep in mind is this. When you multiply two numbers to get you a negative number, it means one of them must be negative and one must be positive, right? But when you're adding a positive and a negative number, what are you actually doing? You're actually subtracting. So sometimes what is very useful, especially when you get a number here that has a lot of multiples, a lot of factors, is I like putting it on the side and writing them down. So 1 times 12, 2 times 6, 3 times 4. Okay, there are our factors. Now, we want to make 4. Which of these, whether we add or subtract, which really we should know we're subtracting since this is negative here, which of these gives us 4? Hopefully you said 2 and 6. Now, right here, 2 plus 6 is not 4. What needs to be negative? Well, for this to be a positive 4, the negative must be on the 2. Okay, if it was on the 6, it would be negative 4. Okay, let me make a box. First term, w squared. Right here is our constant, which is negative 12. Then we have our 2 extra, right? Don't forget that variable that goes with it. So negative 2w and 6w. Okay, let's do what's in common. Common on the left is w. Okay, let's watch out here. What's common on the right? 2 and 12 is 2. But that negative 2 is negative. That 2 is negative. So when that top one right there is negative, I bring the negative with it. Just like this up here. Now, when I look at the top, what's common here? W. And on the bottom, what's common here? Well, 6. Now, because the 6 is positive, this stays positive. Okay. It doesn't matter if this back one here is negative. It's about these two. Okay. So if one of these is negative or both is negative, we pull out that negative. See, they were both here negative, so we pulled out both negatives. Here, only this one is negative, so we pull out that negative. That means our answer is W minus 2 times W plus 6. And again, you can check your answer by multiplying. Okay, let's check one more here because this is a different setup, right? Our middle term here is negative. Our last term here is negative. So I have 1 times negative 18, A times C, which gives us negative 18. So we're asking ourselves what two numbers multiply to give you negative 18, but add to give you negative 3. Okay. Now, what I pointed out before is since this is negative, that means one of the factors is positive and one of the factors is negative. So we're actually subtracting and not adding. Again, 18 has a lot of factors to it. So I might write down another list. Let's see. We got 1 and 18. We've got 2 and 9. And then we have 3 and 6. Which pair of numbers could give us negative 3? Hopefully you said 3 and 6. So when I put 3 and 6 here, again, this doesn't add up correctly, right? Because one of them needs to be negative. So is it the 3 that's going to be negative or the 6? Well, to get negative 3, our 6 must be negative. Let's draw my box. First term up here, constant down here, and then my 2 other ones, don't forget the x, 3x minus 6x, or negative 6x. Okay. Let's look at the left. The left here, we have x, right? Because it's the top one there that I'm looking at, the first one. Right here, we have 3x and negative 18. Well, that 3 is positive, so I'm going to do 3. Okay, because 3 goes into both of those. My top here, what they have in common is x. And on the bottom here, well, what's common between 6 and 18? Well, that's 6. But that 6 is negative, so I'm also going to pull out that negative. So the answer is x plus 3 times x minus 6. Again, multiply it out if you have to do correct. Make sure you have the correct answer. Now, what I want you to do is pause this video now and do the first 2 problems on your 4-question sheet. All right, hopefully you checked in with me, got those corrected, fixed any little mistakes that you needed, and now we're going to move on. All right, so the good thing about a grouping method instead of a box method is it's kind of higher level. You're not drawing things out, okay? Where the 4 terms come into play could be something where, see how these are 3, but we change that -7 to -2, -5. That makes 4 terms. That might help. But here's what grouping is like. Sometimes there's a question like this on ACT, so it's good to know. When it comes to grouping with 4 terms, what we're going to do is we're going to look at the first 2 terms and the second 2 terms. And we're going to ask ourselves what's in common and pull that out. Factor that out. So what's in common between 3x cubed and x squared? Well, they both have x's, so let's go with the lowest exponent, which is 2. So I'm going to pull out this x squared. And when I factor that out, just like we did with the greatest common factor, that leaves us with at 3x. And then plus, well, x squared divided by x squared is 1. Okay, that's for the first one. On the second one, we're asking ourselves what's in common between -6x and -2. Now, when this term right here is negative, you have to pull out that negative also. So what's common between 6 and 2? Well, that's 2. And since that's negative, we're going to bring out that negative. Okay. Remember, bringing out that number is like dividing by that. So -6x divided by -2 is 3x. -2 divided by -2 is +1. Now, you know you're on the right track when these 2 binomials in the parentheses are the same. When they're different, we need to check our answer, okay? So for our final answer, what we do is we say it's our outer terms creates binomial. So x squared minus 2. And then we multiply it by the binomial in the parentheses. And we just factored 4 terms. Okay, like I said, you can do that with this stuff. Maybe I'll show you down here after we do the box method. I'll show you what the grouping looks like, and you can choose what you want to do. Okay, example 4. We're going to take the same setup as we did for the basic trinomials. Okay, that's why I taught you that process with the box method earlier, just so we can stick with the same process. Okay, so we're going to go our a, which is 2, times our c, which is -3. So we get -6. Now we're going to ask ourselves what 2 numbers multiply to give us -6, but add to give us, well, what's that b value right there? Hopefully you said 1. All right, let's think of our factors of 6. We have 1 and 6. No, it doesn't give us 1. We have 3 and 2. Oh, wait, 3 and 2 work, right? Because since this is a -6, that means one of these has to be negative. So since we're at a +1, that means our 2 must be negative. Okay, I'm going to do the box down here so I can show you grouping over here. So then we go to our box. Remember that first term goes in this upper left-hand box. Our constant goes down there. Don't forget the sign with it. And then these two numbers go here. Don't forget the x with it. So 3x and -2x. Okay, on the left, what's common? 2x, right? Now it's not negative because this top term is not negative. Okay. Now on the side here, what's common between 3x and -3? 3. It is not negative because that 3x is not negative. Okay, let's look at our top. What's common between 2x squared and 3x? Just 1x. And on the bottom, what's common between -2x and -3? Well, there's nothing really in common between 2 and 3, so it must be 1. Okay, when you can't see it, it's probably 1. The other thing we have to keep in mind in this case is because this 2x is negative, that means this is a -1. So the answer we get is 2x plus 3 times x minus 1. Very good. I'm going to show you how to do grouping, but this is the only time I'm going to show you if you choose to group. So we still have to do this a times c stuff and figure out what 2 terms. But if you would rather do grouping, the way we did this is now we rewrite this problem as 2x squared, but instead of saying this 1x here, I'm actually going to put in this plus 3x minus 2x, and then minus that plus or minus that constant, so -3. So see how I have 4 terms now? So I just use these 2 as my middle term. And now I can put parentheses around this and start grouping. So what's in common here? X, leaving 2x plus 3. What's common here? Well, 1. But remember, I have to take out that negative with it. So -1, leaving 2x. And negative divided by negative is a positive. And remember what I said before up here. We take these 2 terms out front, and that creates that binomial. So x minus 1. And then the binomial insides that are the same. That's how we knew we did it correctly. You get 2x plus 3. Okay, again, you can choose which way you want. Again, if you learned a different way and it works every time for you, do it. I just want you to be able to prove to me why it works. Okay, we're going to do a couple of practices because, again, I need you guys to get this correct. This is very important. Okay, now, I know this one can get a little tricky here with this being so big, but I also don't mind it being so big because you actually are ready to attack it the same way we did the other one, right? So a times c, so 10 times 12. Oh my goodness, 10 times 12, well, that's 120. So what 2 numbers do you multiply to give you 120, but add to give you 23? This is where it takes a while, right? So all I'm going to do is put it on the side, and yes, this might take some time, so some of you might fast forward right now. 1 times 120, that doesn't work. 2 times 60, 3 times 40, 4 times 30. We're still not at 23 yet. 5 times, let's see, 5 goes into 12 twice, so that's going to be 24. Nope, no 23 yet. 6 times 120. Woo, 120 has a lot of factors. 7 doesn't go into 120. 8 times 15. Do we have to go any further? No, because here's our 23 right there. So I'm going to put 8 and 15. Do we have to check our negatives? 8 times 15 is 120. 8 plus 15 is a positive 23. Excuse me. Perfect. So now we can draw our box. Again, if you like the grouping, do the grouping. You should come up with the same answer as I do. First term. Excuse me. Constant. My 2 extras, so 8V, 15V. Look at what's in common. Sorry, guys, I have a tickle in my throat. Excuse me. Let's go left row. What's common between 10 and 15? 5. What's common between V squared and V? V. All right. What's common between 8 and 12? Be careful. Don't say 2. What is the greatest common factor between 8 and 12? Hopefully you said 4. What's common on top? So what's common between 10V squared and 8V squared? 2V. What's common between 15V and 12? 3. So our answer is 5V plus 4. We don't have to worry about negatives, right? Because there were no negatives. And then 2V plus 3. Again, if you multiply that out, we can check our answer, and this works out nice. I like checking the first 2 and the last 2. 5V times 2V is 10V squared. 4 times 3 is 12. Very good. All right, now we're getting into more elaborate questions, so watch out. Remember at the beginning of this lesson, I said the first thing you always want to do is what? Find the greatest common factor, because this makes all your multiplication for factoring easier. It's easier to find factors of smaller numbers. We know this because of the 120 that had so many factors, right? But wouldn't it have been nice if we could reduce it somehow? So the first thing I always want you to do is find that GCF. So what's in common between 6, 14, and 4? Hopefully you said 2. So when I look at this, I get 2 times 3y squared minus 7y plus 2. So, right, I factored out that 2. Do you guys agree with me? All right. Now, what I'm going to do, usually I highlight this, but I have a yellow paper. So I'm going to underline this just so I don't forget about it. It doesn't disappear. I'm going to ignore it right now, but it doesn't disappear. So now I'm going to treat this trinomial here like the last 2 we did. So I'm going to look at A. So A, which is 3 in this case, times C, which is 2. It gives us 6, a positive 6. So we're asking ourselves what 2 numbers multiply to give us 6, but add to give us negative 7. Well, 6 is either 1 and 6 or 2 and 3. Which one makes 7? 1 and 6. But where's our trick? They both need to be negative, right? Negative times a negative is a positive right here. Negative plus a negative is a negative. Now we're going to do our box. So again, I'm focusing on this trinomial right here. So I have 3y squared, our constant is 2, and then our other 2 numbers, -1, but don't forget our variable y, -6y. On the left, what's in common? What's common between 3 and 6? 3. Y squared and y. It is not negative because it's that top number that I care about. Over on the side here, what's common between 1, y, and 2? Well, when you say nothing, doesn't mean you put nothing down. It means you put 1 down. And then this top one is negative, so this must be negative. Okay, let's look at the top row. What's common between 3y squared and 1y? Well, it's just y. What's common between -6 and 2? Well, hopefully you said 2. And it is negative because that 6 is negative. Our answer to this is 3y minus 1 times y minus 2. Now, here's why I had you underline this greatest common factor, because we have to attach that to our answer. If you do not attach that to your answer, it is wrong. Remember, I said it doesn't go away. We're just ignoring it for now. So that is where a lot of people lose points, is that they forget to put their greatest common factor back in their answer. All right, D. I'm going to try to go through these a little bit faster, just so we're not having so much time on this lesson, okay? We learned at the beginning that greatest common factors don't just have to be numbers. They can be the variables too, right? So if we look at the number itself, it is